Oh, we don't need to look at that. We've already beat, I'm on the wrong mouse again. I even labeled these mouse so I could get them right. But I want to pull up that print real quick. So we've located where our holes are going to be in relationship to Z0 already. So let's jump to our program and put those in the correct place. So what I need to do before I bring in my toolpath is I need to switch to my drill. What is going to be my drill tool number? 3. Why is it 3?
Because we've already used tool 1 and 2.
Right, so it's my next sequential tool. So let's insert a tool. Tool number is going to be 3. 17, 30 seconds drill. I don't need to move to a certain place to load it. I haven't touched off tool 3 yet, so the tool height is grayed out right now. Tool diameter is 0.531.
What about spot drilling?
Good question. What about spot drilling? We're not going to do it. What is the purpose of spot drilling?
So it doesn't wander.
So my drill bit doesn't wander from where I'm trying to drill it. Anybody who has hand drilled has had to deal with that. Your hole is basically going to go anywhere but where you want it. In this rigid of a setup that we are going to have, we don't need to spot drill for the purpose of locating a hole. The reason we spot drill primarily in the CNC world is to create a lead-in chamfer. So we are going to put a 1/4-20 thread in the side of this part. We will spot drill there to get a lead-in chamfer. We'll also do it to have an edge break at the top of a tool. We're not going to do that here because I need a 1-inch spot drill to edge break this counterbore, and they're like $100 a piece. So we're going to do that in another fashion. Good question though. All right, spindle RPM. So let's go figure out RPM real quick. Pull up my calculator. Go ahead and maximize that guy. Let's do it big here. All right, so I am using 100 SFM because I'm using a high-speed steel drill on low-carbon steel. So 100 times 3.82 is, the answer is 382. Let's see how I did that off the top of my head. So look at me saving a step. 382 divided by diameter of the tool, divided by 0.531. The answer is 719. So there is our RPM. 719. We're going to turn it clockwise. I don't have coolant on this machine. And yes, it is an actual tool change. Remember, when I say yes to a tool change, it's an op stop. If I say no, the machine is not going to stop. And the purpose there being, if I'm going to use the same tool for another purpose, but maybe I want to change the RPM of the tool, I can. All right, I'm going to say yes, and I'm going to accept it F10. So cool, so now I have my tool loaded, so let's go to my tool path. Currently, I'm in my insert screen. We can tell because of the soft key selections at the bottom, and then I have my empty box between operation 10 and 11. I'm going to put a cycle in there, so my drilling is under can cycles. And under drill, I've got several options here. My drilling options is drill, drill a bolt hole circle, drill an array, or drill repeat. We're not going to go into all of them today. We're going to go into a specific one for this vice jaw, and it's going to be drill array. So once I click drill array, it brings up the array toolpath questions. To help us out, to visualize this, I'm going to click on help. So this is nice. So now I have a visual aid as I go through here. It's going to help me out. So anytime toggle is visible down here, that means I can change the active line. So I'm going to press F3. So that's what straight drilling looks like. It's going to go to the full depth and come straight out. The problem for us doing this is it's going to make 2 chips as it goes down because of the 2 cutting edges. And the chips are going to be like 18 inches long. And they're going to wrap around the drill chuck and they're going to create havoc. So that's not good for us. If I had a 1/4 inch piece of material I was drilling, yep, I'd be all over this. But it's not going to work for us. Chip control. So I'm going to toggle deep hole. The purpose of deep hole tool paths is to extract chips. So as the drill goes down, the flutes get packed with chips. I yard the rapid out of the hole with the drill bit. The chips come out, and I'm able to go back down. So deep hole is for chip extraction. Chip break is where that 18-inch chip I told you a moment ago, my feed is going to pause for a second, and the chip's going to break. So I'll have shorter chips. So either deep hole or chip break is the answer for us. As a more correct answer, here's what I'm going to do. I'm going to go for deep hole. Because when that drill bit comes out of the hole to clear chips, I'm going to pause it, and I'm going to put a squirt of cutting oil in that hole to help out my high-speed steel drill. If I had mist coolant on this machine, I would probably just do chip break, and I'd just have that mist blowing in the hole the whole time. So different techniques for different machines with different coolant. So let's go back to deep hole. And now let's start answering these questions. The first one is, which hole are we going to start on? We talked about this earlier, and we decided the left-hand hole. From our print, that's not my print, that is a calculator. From our print, we decided that this left hole is 1.938 from x0. So, 1.938. Oops, Damon. Yes, good catch, guys. Negative. We could have started on the right-hand one, but that wasn't my intention. So, that's good. In Y, what is the location of our hole in Y? Okay, so the difference between Y0 and our hole is 0.0725. Positive or negative? Okay. Doesn't matter for op1. Op2 is where it really matters. Since that hole's off center, I flip that thing over the wrong way, and then I come try and break the edges on the backside. So let's keep that in mind. You'll break the tool, and someone's going to do it, and we'll see the point then. So let's do positive. Let's do it away from us. 0.0725. Good.
So, so in that case, would that be a way of shifting the origin?
No, would not. Would not. If we wanted to move in op2, we noticed we weren't breaking the edge evenly, we wouldn't come into the tool path and change it. We would go into our work offset because all of our tool paths would need to move to line up with those existing paths. Okay, here's the interesting part now. Now we're getting into some of the array stuff. So what is the increment to our second hole in X? Notice over to the right, it says incremental. So from this negative 1.938, what is the increment? 3.876? Fantastic.
3.876.
Check this out, guys. Just to double check, I'm going to do the math here. 1.38, oops, Damon, that's not right. 938 times 2. 3.876. Good job. Biscuit. All right. What is the incremental change in Y to get to the second hole? 0. There is no change in Y. So this is an interesting way. We're using array, where typically we're doing a grid, but we're cheating it. We're not going to move in one of the axes. So you're right, that's 0. How many holes do we want in X? 2. How many holes do we want in Y? 1. Good, you're getting that array thing figured out. Okay, we already talked about surface height once. Where are we going to find surface height for this drilling toolpath? It's going to be at 0, Z0. Clearance height. This is where the tool is going to go when it retracts from one hole and goes to another. And this is where we're going to rapid to drill our first hole. And it defaults at 100 thou. 100 thou isn't much when your machine's rapiding, so we do have to use our crash mitigation steps on our way here. But I'm going to stay with 100 thou. Go big or go home. Rapid to depth. This is kind of weird. So actually, forgive me, I just misspoke a second ago. Clearance height is the height we're going to go to when we retract from one hole and go to another. Rapid to is where the machine's going to G00 in on the way to our hole. So it's where the machine's going to rapid to in Z to get to our first hole.
To the 100 height?
Yes. We're going to leave it at 100. So what I said, I just said it wrong. We are going to rapid to 100 thou above our part, but it's this line that is deciding that. I can rapid and I can retract to different planes, I guess, what we can say here. Okay, depth. All right, guys. Let's do this again. Let's pull up that calculator. The depth of this hole. So, the thickness of my part is 0.775. The thickness of the stock on the bottom is 0.1225. We already calculated the drill tip on our 35 degree to be 110 thou tall. So we're going to add our drill tip to it, plus 0.11. Oh, what did I do wrong?
I think it's the memory.
0.775 plus, yep, there we go, 0.1.
It should be 1.77. Well,
Okay, I think we're doing good. So here's the thickness of my part, the thickness of the stock on the bottom of the part, my drill tip, that 135 degree drill tip, 0.110. Oh. I divided because I didn't hit plus. Geez, this is painful. Okay, yeah, I'm shush. Of course I'm recording it. 0.775 plus 0.1225 equals plus 0.11 equals. Now we're going good. Jeez Louise. And now I'm going to throw that margin at it, that 50 thou that I want because of variance. Plus 0.05. Doesn't look like the number we got before, does it?
no, it should be 2.
Should be 2.
Yeah.
2 what?
2 point.
No, it's not 2 inches. I'm not drilling 2 inches. I'll be in my vise.
It was 1.0375. I don't know how to...
0.775 plus 0.1. Huh? The thickness of the part, right? 775?
755.
Yeah, this-
Yeah, you're off by...
755. Thank you. Jeez. My part is 0.755 plus 0.1225. Stop laughing. Equals plus 0.11. Oh, good Lord. This is ridiculous. 0.755. I'll look at the screen this time. Plus 0.1225. Okay, that's looking good, right, guys? All right. Plus the drill tip. Plus 0.11. Enter. Okay. Plus my margin. Jeez, that's it. Wow, that was painful. Okay, 1 inch 37 thou. 1.037. I don't need to make it negative here because I'm drilling a hole. It knows I'm going in that direction. Whew. So That hole is going to go through the bottom of the stock now. We're doing that for chip evacuation. What is going to be our drill increment? You see, good question. What does that mean? You look over in our help screen. It is how far it's going to drill before coming back out. So what we're thinking about here is how long do you want the chip to be? If it keeps drilling, it's making a chip. So I'm going to say 200 thou, and we'll see what we like about that chip length, okay?
So
0.2.
it's going to drill an extra 200 thou?
Negative. Drill increment. So this tool path, this deep hole tool path, it's going to drill a depth, retract. Drill a depth, retract. Drill a depth, retract. So what we just populated is what depth it's going to drill before it retracts.
Oh, okay.
So
it's
you're
gonna
setting
go
your
200
pack,
thou.
3 or 4
I'm setting my pec depth.
setting your pack.
Setting my pec depth.
Okay, cool.
Groovy. All right, here's our rapid 2. So when it's, after it's pecking and it's coming out to clear those chips, this is where it's going to. I'm going to bring this up to 100 for us, just so I can get some cutting oil in there without, so I can get some cutting oil in there. Plunge rate. We've had this plunge rate a couple times now, and they talk about plunge rate, and it is the Z feed rate. Z feed rate. So, what is the feed rate for my drill? What is the feed rate for my drill? Yeah, right. Please give Damon a calculator. So, what did we come up with for an RPM? 719 for an RPM? So it is RPM 719 times the number of flutes times 2 equals divided by chip load. Our chip load is going to be 2.5 thou. And it's straight multiplication times 0.0025. Our feed rate is 3.5 inches a minute. 3.5. Sure glad I didn't lose my brain there on.
44 inches per minute.
It's, yes, it is slower. All right, so let's check, and it's one reason it's slower is the RPM is so low. All right, let's graph it. Okay, so here is a Z look at our part, and we see these incremental stops here. These are our pec depths. 1, 2, 3, 4, 5, 6. So there's going to be 6 pecs, 6 sets of chips. The spacing looks okay. The yellows are feeds, the reds are rapids. Why are the rapids going through the table right now? I'm going to spare you. It's because we don't have G54 set. So when G54 is 0, 0, 0, this is the picture you get. So don't worry about that now. We shouldn't, we best not see the rapids going through the table here when we have our G54 set. Okay, now let's take a look at the top view. And once again, this dude can go below the talon grips because it's in the middle of my part. There's nothing there for it. Looks like it'll stay out of my vice jaw. Yay. And there we go. Those are looking in the right place. You notice they're off the y-axis about, I don't know, it could be 72 thou. Yes.
So how far is it down until you get to the bottom of your vise?
How far is it until I get the bottom of my vise? Whatever the height of that jaw is. 1.7, it's almost 1.5 or 1 3/4 inches. So, that's looking good. Let's escape out of there. Wrong keyboard. Oh boy. Did not respond to the escape. All right, now let's accept this toolpath and save.